So we're going to get into something called the law of cosines. But before we do that, let's talk about some unique qualities about a triangle, and one in particular. And that is the triangle side length restriction. So if you consider a triangle, and let's consider this one a triangle, right? And this one's oblique, it's not right. It says in any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining side. Okay, so let me just get rid of this here. There we go. So what does that mean? That means that if you have the side A plus the side B, those two have to be bigger than the side C. If you have the side A plus the side C, those two have to be bigger than the side B. And if you have the side B and the side C, they have to be bigger than side A. So that's the triangle side length restriction, and that's what it means. Okay, if this is violated, then you do not have a shape that can be called a triangle. Okay, it's not a triangle. All right, so let's go ahead and take a look at the law of cosines. Now, we're dealing with triangles that are oblique. What is an oblique triangle? Okay, they're triangles that are not right. Okay, they do not have a 90-degree angle. All right, so if we're looking at the law of cosines, it says in any triangle with sides A, B, and C, you have something that looks like this. A square equal B square plus C square minus 2BC cosine A. And there's kind of a pattern here. You have B square equals A square plus C square minus 2AC cosine B. And C square equals A square plus B square minus 2AB cosine C. Now, if you look at it, it's almost like you're looking at a modification of the Pythagorean theorem. And that's kind of what it's loosely based on. So the law of cosines, we're going to take a look at. And suppose I have A square equal B square plus C square minus 2BC cosine of A. And I want to solve for the side length A. Well, what I would do is I would apply the square root property. So I'm going to take the square root of this. Okay, so what is A? A will equal the square root of B square plus C square minus 2BC cosine of A. Okay, so that's what the side length A would equal using the law of cosines. Now, if we're trying to solve for an angle given this information, so let's go ahead and pretend that we're going to undo that. All right, what we're going to do is we're going to isolate the cosine of A first. All right, so I'm going to move, and let me use a different color here. I'm going to move these two over here to this side in this part of in this manipulation of the formula. A square minus B square minus C square. Now what I'm going to do is I'm going to divide by this part right here. Okay, negative 2BC. I'm going to divide by negative 2BC. So divided by negative 2BC, that will equal my cosine of A. But that's the cosine of the angle. That is not the angle itself. So let's come back up over here and let's talk about what the angle A then looks like. Well, A will equal the cosine inverse of A square minus B square minus C square, all divided by negative 2BC. So that little cosine minus 1 on your calculator, you'd have to use it here. Okay, now I'm going to go ahead and write out the other variations of this formula. All right, if you're looking for the angle B, it is going to be the cosine inverse, and it's all a pattern. Okay, it is B square minus A square minus C square, all divided by negative 2AC. So you take the cosine inverse of that, and then angle C is going to be the cosine inverse of, and you might have guessed it, it's C square minus A square minus B square, all divided by negative 2AB. So that's what it looks like. Okay, so those are the three variations of the formula. Of course, if you are trying to find a side, you're going to use one of these. And if you're trying to find an angle, you're going to use one of these. So each variation of the formula has a different significance. Okay, so let's go ahead and take a look at an example. And this is a really good example. It's a classic example of what you might see on an assignment somewhere regarding the law of cosines. So it says a tunnel is to be built through a mountain. So we're looking at that tunnel, and I'm going to highlight it right here. There's the tunnel. All right. To estimate the length of the tunnel, a surveyor makes observations pictured below. Approximate the length of the tunnel. So what we're going to do, and what I'm going to do, is I'm going to label this triangle here. Now let me just pick a color. Let's see what color would work. Maybe red. All right. So I'm going to label my sides first. This is side C, this is side A, and this is side B. Okay, so now I'm going to go in and I'm going to figure out, well, I'm looking for side C. So if I go back up to my formula for the law of cosine, I'm going to need this formula right here. Okay, so let's go ahead and write that one. I'm looking for side C, so C square equals A square plus B square minus 2AB cosine of C. Right? So let's say that I have C equal the square root of A square plus B square minus 2AB cosine of C. And now I'm going to fill in what I know. Well, I know that A is 212, so I'm going to put 212 squared. And B is 388, so I'm going to put 388 squared minus 2 times 212 times 388 times the cosine, and let me extend the root here, cosine of the angle C, which is 82.4 degrees. So your calculator does need to be in degree mode. Okay, and once you plug that in your calculator, okay, I wouldn't expect you to use anything else, rounded to the nearest whole number, I get something like this, 417 feet. So this is an application of the law of cosines. And if you liked this video and it was helpful, be sure to like and subscribe.